Good afternoon. My name is Ron Huizinga, and I'm Product Manager for ER Studio. I'm very excited to be with you today, as I've just recently joined the organization. Prior to joining Embarcadero, I had the opportunity to work with not only ER Studio, but a number of different modeling suites over the past 30 years. In the previous 20 years, I functioned as an independent consultant, focusing primarily on enterprise architecture and data architecture in particular, as well as project management on a number of large engagements. Before that, I worked for a couple of different consulting companies, and prior to that, I was CIO of a manufacturing company, always with a focus on information systems and data architecture. The topic I'm going to discuss with you today is known as Taming the Wild West of Data. In this session, I'm going to share with you some of the experiences that I've seen over these engagements over the past number of years. Today's discussion will take us through a few of the following areas. Firstly, we'll talk about business alignment and how IoT can respond to business needs. Secondly, we'll talk about data architecture, but also enterprise architecture in general. What I will do following that is walk through some of the things that I've run across in terms of charting with the information landscape in some of the larger corporations I've encountered. And before we wrap up, we'll have a discussion on data maturity so that you can figure out where your organization is positioned on the data maturity scale. At the end of the presentation, we'll also have some time for questions and answers. It's important to recognize that data management and information management isn't just a technical responsibility of IT departments. More importantly, it's a corporate responsibility and needs to be part of the business strategy. As long as 14 years ago, Tom Peters recognized this and gave us the following quote: "Organizations that do not understand the overwhelming importance of managing data and information as tangible assets in the new economy will not survive." It's interesting to see what happened to a number of corporations based on the economic upturns and downturns that followed that time. Many did not survive, and many were absorbed by other organizations. Larger corporations that have absorbed other companies are now struggling with the poor information assets that were part of the acquisitions. Let's take a look at some of the problems that occur between business and IT and what causes the misalignment in particular. See if any of these symptoms actually apply to your organization. Within IT, there's a focus on short-term projects rather than strategic initiatives. Some of these can be driven by the business, as in terms of departmental solutions, and others are driven within IT itself. In many corporations, there's a proliferation of disparate systems. Now, this can be for a number of reasons, one of which is the fact that other companies are acquired and a number of systems come into play. It takes time to actually migrate the corporations onto the systems of record, leaving a number of systems including ERP solutions and mismatched departmental solutions. Something that's become more prevalent in recent years is also software as a service. These solutions present their own challenges as the information is not contained within the walls of the corporation itself. So there are additional challenges such as, is the information secure? Where is the information hosted? If the solution provider goes out of business, what happens to the information? Something that's common in very large corporations, and we're seeing it more and more in smaller corporations as well, is that a lot of systems are put into play, but the older systems are not retired sufficiently. In some corporations, there are many obsolete legacy systems, which just leads to a lot more complication within the landscape. Quite often this is due to the fact that there's absolutely no decommissioning strategy, and this is fueled by the short-term projects that we discussed earlier. A lot of times these short-term projects focus on just getting in a new solution and migrating some of the information from old systems to the new, but they don't complete the circle by actually decommissioning the old systems. What we also see as part and parcel of this is because there isn't a strategic focus, there's no integration strategy as well. This is characterized by a number of point-to-point interfaces within the corporation. There's no consideration of a more robust solution such as an enterprise service bus and other data integration strategies. On top of this, we are now seeing businesses trying to do data analytics. A lot of solutions proliferate, so companies are trying to pull the information into data warehouses, trying to build data marts and data cubes on top of that to drive the analytics that they need. However, there hasn't been focus on the data quality of the source systems, so the poor data quality actually flows through into the analytic solutions. This can lead to very poor decisions and often incorrect decisions, which can jeopardize a business significantly. A lot of this is hampered by the fact that there is no long-term architecture focus. Some examples of the above that I've encountered in the past are extremely disturbing. For instance, I've run into organizations that had employee information scattered across a number of different systems. They could not answer the questions that would appear to be simple, such as how many active employees do we have on a given day? This proliferation of systems, as well as the mixed-matched ERPs, SaaS solutions, obsolete legacy systems, are all portions of what I call the Wild West of data. A lot of this is fueled by the fact that companies use an expense-based approach rather than an investment-based approach to IT. They need to recognize that IT and data in particular is an investment, and it's an important building block of the corporation. As stated previously, architecture is a fundamental underpinning to help us tame this Wild West. Some of you might recognize the Winchester Mystery House, which is outside of San Jose, California. The building of this mansion was commissioned by Sarah Winchester, the heir to the Winchester gun fortune. Externally, it looks like it's a very beautiful mansion, very complex, and in a beautiful setting. There's some interesting things about this particular home, though. Let's look at them. This is something that's evolved over a period of 38 years of construction, and there were 147 different builders. On top of that, there were no blueprints, and there was actually no planning. It was built as on the go. Interestingly, this is a parallel to the way a lot of solutions are built in IT today. They've evolved over a period of years. The people that started building the solutions are no longer there, or systems have been pieced together in an integration fashion as companies started to acquire the different departmental solutions, putting point-to-point interfaces together, and trying to make a hybrid solution work. In essence, this can be referred to as organic growth of the company's solutions. There's also a lack of continuity. There have been many fingers in the pie over a long term, and quite often people that started the solutions are no longer around to support them, and nobody actually knows how they work. Because they're pieced together, there's also no design or strategic focus that we can rely upon to determine what's really there. So as a result, we have to go back and figure out what actually is there. Let's look at the Winchester House. Because of this disjointed construction, here's what really happened. Overall, there are 7 stories in different places in the mansion. The outcome, though, has a number of disturbing characteristics. There are 65 doors that go to blank walls. There are 13 staircases abandoned and 24 skylights and floors. The parallel to this is some of our systems where information should be moving back and forth between systems, but the systems do not talk to each other. There are 160 rooms and 950 doors. There are 47 fireplaces and 17 chimneys, so the lack of design is readily apparent. There are miles of hallways, and there are secret passages in the walls. There are also 10,000 window panes, and all the bathrooms in this mansion are fitted with windows. So this mansion that looks quite beautiful from the outside is very disturbing on the inside. It's analogous to when we open the hood and look at our underpinnings of our IT solutions today. When I walk into a larger organization, I'm quite often asked to figure out what the data landscape looks like. So I'm going to walk you through a few brief steps of how I tackle that, and in particular, I'm going to talk about how I tackle it using a product like ER Studio. First, it's important to identify what are the candidate databases that we are concerned about in this landscape. This in itself can be a very daunting exercise. I've been in corporations when I asked the DBAs how many databases they had, they were unable to give me the answer immediately. Upon conducting a lot of analysis and research, some companies have thousands of databases. Not all of them are important to us from an analytical point of view because we have different versions that come into play, such as the development, quality assurance, and production versions of the same databases. When charting the landscape, we literally want to look at just those that come into play in the production landscape and how the information flows between them. Even so, we may end up with a number of different databases from a number of different vendors. In many customers, I found a mix of all different brands: SQL Server, DB2, IBM mainframe, various versions of Oracle, not to mention a proliferation of desktop databases such as Access and some SQL Server desktop databases as well. It's a huge undertaking to pull this information together, but we have to go through the exercise to determine where the information is in the company. The SaaS solutions I talked about earlier complicates this even further because we may not be able to actually find the databases and the information that's in them. We may have to find different ways of mapping out what those databases look like because we don't have access to the schemas themselves. For the databases that I do have access to, I would reverse engineer the existing databases into ER Studio models. This gives us the fundamental building blocks to try to start analyzing database by database the types of information we actually have. Now you can imagine when we look at all of these databases that were built by different people over a period of years, that naming conventions are totally different in all of them. Many databases from the past have coded table names and coded field names. Quite often this convention is three-letter acronyms separated by underscores or three-letter mnemonic abbreviations separated by underscores. However, some of the newer databases use Pascal case naming, and just the naming conventions by the different users and designers are different. So what we want to do is database by database, we want to try to apply uniform naming conventions to the logical layer of our models. Examples of this are as follows. Perhaps in one database, the idea of customer is CST as a table name. So the logical side we would call it customer when the physical layer is CST. In another one, it may be CUS on the physical layer, but we would want to apply the same logical naming convention of customer. By going through and doing these fundamental building blocks, we can then start to build up what our data dictionary looks like and what the business concepts are that are represented in those databases. I'll talk about this a little bit more on the next slide. The next thing we want to do is really start to analyze the redundancies and gaps between these systems. The redundancies in particular are important to us because we want to know for those redundancies what the source of truth is and how the information flows through the systems and how it's modified along the way. Additionally, in order to tackle the information, we can apply more classification to it through the metadata capabilities of the tool. More on that in a few moments. I've touched upon this already in terms of the information flowing through different systems, but one of the things that we can do in ER Studio is we can start to establish data lineage, or something I like to call chain of custody. The point-to-point interfaces we talked about earlier show us some of the actual data lineage that occurs. However, to do an enterprise data lineage, we have to see how that flows across all the systems. So for instance, if I buy a physical asset, such as a piece of capital equipment or machinery, what's the system of record for that? What systems does that information flow to? How is the information modified on the way through those systems? By doing that, we are establishing what's called the chain of custody. Within ER Studio, we have a naming standards utility which is extremely powerful. What it allows us to do is to take those abbreviations that we talked about earlier, and we can actually create translations. Quite often people do this when they forward engineer, when they're starting from scratch on our database. They'll put in the English names in the logical model, then they'll generate the physical names by using those shorter abbreviations. However, the capability is even more useful when we're trying to do something like this data landscape mapping. In effect, what we're doing is we're doing in reverse order. We're taking the English names, mapping them to the abbreviations, and we're literally building up what the business equivalents are. So for instance, where we saw CUS, it would map to customer. Where we saw CUST, it would map to customer. Where we saw CST, it would map to customer. So we would have 3 different tables and 3 different systems with those physical names, but they're all tied back to a concept called customer. Another capability within ER Studio that helps us tie this together even further is the universal mappings. Once we've brought things back to this common name, we can then say that they are linked together so we know where all the manifestations of customer exist in our system. And we can apply this to all of the other types of business objects that we encounter as well. Company, employee, vendor. Vendor is a very interesting one because quite often we have many different names: vendor, supplier, etc. Now, as you might gather from what we were talking about on the previous slide, data modeling really is an exercise in naming. Let's look at a couple of other things now. Here's a sample ER diagram that was done in ER Studio. The circled area on the one entity is how we can actually show the attachments right on the diagram itself. This is some of the metadata I was talking about that actually helps us to classify the tables or entities further. So for example, on this particular one called an equipment component, if I'm doing a SOA type of paradigm in my development, I may have a number of tables or entities that actually comprise a business object named equipment component. So all of those that participate in those class, or I actually tag with which business object they belong to. So in a SOA type of environment, we can then develop the code for persisting the business object for equipment component. From a data quality perspective, and we really want to know how important the business value is of a particular entity. So we can see different things. We want to focus on the high value entities first, and then prioritize and work our way down to the medium and possibly low value entities and elements within those entities when we're actually putting together a data quality strategy and what we need to pursue. Something that's extremely important and has had a lot of press in the recent years is master data management. Before we can actually apply master data management, we need to go through and classify all of the entities in our models in terms of what is the master data class. Is it master data? Is it reference data, in other words, simple lookup tables, or is it transactional data that is actually created by the system in question? We want to focus on our reference data and our master data first, and then the transactional data, since reference and master data are the building blocks that are used in all of the transactions that we capture throughout our systems. Some examples that can occur are different priorities for different industries. For instance, in retail, what are the important things that we want to look at? Well, it's typically the big 3. Who are our customers? What are our products? And where is the stores that we sell the products in? In a different industry, such as natural resources and mining, equipment utilization may be extremely important, so we would focus on that type of information first. If you do something like a multinational pipeline, physical infrastructure and capacity are key drivers to be able to get source from the source down to the refineries. The important question you have to ask when you're doing data classification and prioritization is, where's the value proposition for your business? Whatever information drives that is the information that needs to be analyzed and enabled first. I briefly touched upon data lineage earlier. Again, I want to emphasize this is the first thing we have to do for every one of those important business concepts is determine what the source of truth is. This can be an arduous exercise, and in certain instances, there may be multiple sources of truth, which can be both confusing and problematic. For example, one corporation that I had done business with previously was trying to classify the employee information. However, they actually delineated different systems for salaried employees versus hourly or union employees. So in effect, they did have multiple sources of truth, and depending on the collective agreements that were in place for the unions, there were multiple different systems in which that information originated. So it wasn't just simply applying source of truth through one concept, it was dividing it up in terms of mapping out which types of information came from which types of systems, and down the line where it was consolidated. Chain of custody is a term that I use to depict the information flow throughout the organization through multiple systems. What's very important to remember is that as a piece of information traverses throughout the organization, it isn't necessarily just through point-to-point interfaces, or in more sophisticated organizations, it's not necessarily something that's just simply flowing through an enterprise service bus. The real interesting aspects to pin down are something that I call swivel chair integrations, and that is where information comes in one system, and it's somebody's job to look at it in one system, translate it, and key it into another system, possibly in a slightly different form. Now, the big problem with this is as soon as we introduce somebody in the mix to actually rekey information, it is possibly error prone and subject to keying errors. So what we have coming from one system may not actually match what's in the downstream system. Also, as the information flows through the systems, there can be a number of transformations that take place. What we want to do is we want to start to map out what the data flow is of these pieces of information in tools like ER Studio and even the ER Studio Business Architect. When we're mapping the data landscape, what we really want to drive down is focusing on the conventions that are being used. I've talked about this in naming conventions. We also want to look at the types of transformations that we're typically doing, and possibly we're using the same tools to do the same types of transformations. For instance, in some organizations, BizTalk in Microsoft Shops is in a lot of use. In some of the older solutions, we may actually have programs that are being written as point-to-point interfaces or stored procedures that are moving information from one database to another. In others, we may actually have link tables that are being used or views from one database to another. It's important to go through those systems and figure out what those conventions are that are in use. What we really want to do is we want to pull this information back into models, such as that snippet that was shown of ER Studio, because a picture really is worth 1,000 words, and particularly once we've applied the naming conventions through standardization, we can start to evolve a picture of what that landscape looks like. This becomes a solid basis for establishing a metadata repository and a canonical model or an enterprise data model for the business. Again, data classification is paramount, and we really want to focus on reference and master data first and transactional data as a second step, as the first two are used in the transaction data. It's been my observation that a lot of the companies that have problems in mapping the data landscape also have a low level of data maturity. So I wanted to spend a few minutes talking about that particular subject. I've put together a grid here that basically looks at data maturity based on a few different items or characteristics, if you will. What we'll typically find is a lot of companies with a low level of data maturity, if we look at data governance, for example, have no data governance in place whatsoever. As they start to evolve, they'll start to do some initial introduction of data governance, typically at an individual project level. And when they get to a point when they begin managing it, they'll start to introduce it at larger program levels. Typically, we only start to see standardization if companies are committed to governance and apply it at the division level, and they become advanced and optimized when they actually start to pull it across the entire enterprise. Master data management follows the same type of behavior. In low maturity organizations, we typically find that there is no formal master data classification. And what I mean by that is if you looked at the previous slide when I indicated in the metadata whether tables or entities were classified as master, transactional, or reference, this means that the organization doesn't have a catalog that defines which classification individual entities fall into. Once organizations begin to mature a little bit beyond that, they have some sense of what master data is, but there's no real integration in terms of repositories or anything that tell them what the master data is. Quite often it's by tribal knowledge, or maybe they have some systems that they've purchased such as ERPs or other solutions where some of the master data is cataloged for them. When we really start managing this across the organization and the enterprise, we start to see master data repositories emerge within the organizations. And as we evolve further, we actually see data management services to help introduce standardization as we continue to mature. Something that's extremely important to get any level of advancement at all is to make sure that master data stewards are established within the organization. And those organizations that are at the top of the game actually have data stewardship councils in place. When we survey the data environment, I've talked about data integration as one of the items that we really need to look at. Generally speaking, if we see a lot of ad hoc, point-to-point interfaces, that tells us that there's a very low level of data maturity or possibly none whatsoever. When companies start looking at this in a little more serious manner, we start to see them react to things. There are still point-to-point interfaces, but they're starting to introduce some common tools, but there's still a lack of standards that comes into play. In order to get to a managed perspective, we need to have a common integration platform, and we need to start introducing design patterns of just how we integrate data in the organization. Standardization is achieved when we actually start to utilize more advanced tools such as middleware. And I'm talking about things like an enterprise service bus, a canonical data model, which is utilized for the transactions within that service bus, as well as business rules repositories. Companies that are truly advanced in data integration start establishing centers for data excellence and ongoing education and training, not only within the IT organizations, but in the business organization as well. And when they're fully mature, data excellence is embedded within the corporate culture itself. Data quality is always an interesting challenge. In many immature companies, we see a lot of silos, and those are represented by the systems that we talked about earlier. The data is scattered in different places, and there are a lot of inconsistencies. Quite often, these inconsistencies are accepted, which is a real cause for concern. When some problems arise, then there's recognition of inconsistencies, but still there's no management plan to address them when we start to take an initial look at data quality. Managed organizations, they start doing data cleansing when they're consuming the data. So for instance, as I spoke about earlier, companies are trying to pull a lot of information into their data warehouses. Rather than fixing the information at source, they end up building a lot of data cleansing utilities just to pull the information into the data warehouses. And that's their attempt at data quality improvement. However, that's analogous to the industrial age when we were actually trying to inspect manufactured products off of assembly lines. It is impossible to inspect quality into a product. What we need to do with information is exactly the same. We need to move back and we need to start introducing the quality of information at source and make sure it permeates throughout the process in which that information is used. In order to achieve a level of standardization, we really need to start to introduce data quality KPIs, and we need to have visibility of conformance and non-conformance in terms of data quality. And there will still be some data cleansing at source as we actually move towards a prevention approach to data quality and we begin to advance. In the optimized organizations, we'll actually see this evolve into a full data quality management practice. When we look at it at a very high summary level, we need to look at a few different things. For all four of these different areas, it's possible that an organization could have a different score in each of the different areas, but we likely won't see a very wide divergence. They may be slightly higher and lower in some, but it's very atypical to see somebody at 0 in one category and 5 in another. It's virtually impossible to achieve that. In terms of organizational behavior, those companies that are at no or a very low level of data maturity don't even realize they have a problem, so they're totally unaware or they deny that it's important. This proceeds up to the levels of chaos, reactive decision making, and ultimately when you achieve standardization, you introduce stability to your organization. To become advanced and optimized, you really need to be proactive, and when you are optimized in particular, your behavior becomes predictive. Everybody knows what needs to be done. The three bars at the bottom are extremely important because when we really look at it, it gives us some high-level indicators of what the impact of this data maturity level is. Typically, when we see a very low level of data maturity, we see IT departments that are primarily focused on technology and infrastructure rather than information and information quality, whereas optimized organizations are really focusing on information and strategic business enablement with that information. Interestingly, because of that, those companies that are a low level of data maturity impose a very high level of risk for a number of factors. And as we proceed up the scale, when we have high data quality, we're introducing a very low level of risk to our organizations. And most importantly, for low data quality organizations, there's also very low value generation of the systems that we have in place and the information that we produce. Whereas when we have a high level of data maturity, we're actually producing high value for our organizations. We need to remember that the data, or information in particular, is the I in IS. We don't have a chance with our applications, analytics, and our organizational decision making unless we're doing that based on accurate and factual information. So as a parting thought, I'd like to ask you, how does your information foundation look today? Is it good, or is it like this California beach house that is starting to crumble because the foundation underneath it is crumbling? I'd like to thank you for attending today. You can actually see more about our ER Studio product family at the URL on the slide. And we look forward to you attending more sessions as we go on throughout the day and tomorrow as well. At this time, I'm going to conclude this presentation, and we will move to the question and answer portion of this session.
Ron, I know there's design patterns for object models and for code refactoring and so on. Is there such a thing as a design pattern for a data model?
Somewhat, and in fact, there are not a lot of public ones, if you want to put it that way. You end up kind of building up a toolkit of some of your own and some of the situations you run into. Interestingly, you mentioned the class models and that type of thing. I've actually over the years had to come up with some patterns in terms of transformation from those class models into relational data models, because while some teams were working at the object level, everything was at the end of the day being persisted in relational databases. So there are definitely some techniques and modeling patterns that help achieve that.
Okay.
If others have.
Okay. Janet has added a comment about there are several good books about design patterns for data models. David Hay has at least 2 of them out there. You can also purchase industry standard data models. Teradata sells some. Another question came in from Sebastian. In your experience, does the level of data maturity correlate with company size or some other critical mass measure?
It's interesting. That's a very good question, and it generally isn't a direct correlation to size. And in fact, some of the larger organizations, just because of the acquisitions and problems they've encountered, have a very low level of data maturity. And what you really need to look at to figure out, where it is going to be is taking the temperature and gauging the level of commitment within the organizations. Regardless of organization size, if you have senior management support to help in these initiatives, you will be able to increase and establish a very good level of data maturity. But if you're in that realm that I talked about in the presentation of everything being expense-based and senior management not recognizing the systems and the data in particular as an investment, then it can definitely be an uphill battle. I'd also like to just interject a little comment about the design patterns for the data models that are available out there, and in particular industry standard models. Again, a lot of them are a very, I guess, a good quick start set or concepts to consider, but I've also seen industry models which tended to be quite academic in nature and not necessarily good to implement practically. So whatever you're looking at, just take it with a grain of salt.
Oh, Gal just made a comment and compliment for you. Excellent session. Really emphasizes the importance of data architecture. Jill has just asked, do you usually just reverse engineer all the databases into physical models, then create an enterprise logical model that defines the data, and then use the universal mapping and domains to link them together and show the data lineage on the data integrations? How do you put that all into one data model?
That's kind of the basic steps, because you really are going through a building block block approach. First, you've got to figure out what it is you've actually got. So you need to apply the naming conventions and start prioritizing through some of the other metadata tagging, just to, for lack of better words, it's like cleaning the garage. You've got to start to put the things into piles of what you analyze and to decide which are the most important ones you want to go after first. Now, having done that, I actually do it in multiple models, and then I use the universal mappings between those models so I don't have everything all tied up in one big monster model. And then the data lineage is a combination of using data lineage such as an ER Studio. But when I talk about things like the chain of custodies, using basically business process modeling is very important as well. And you can utilize the business process modeling tools to help you lay out a data flow as well. And if you use the business process tool in ER Studio, the entities in the data model are actually available to you as data stores as well. So you can map out where things are going and where they're coming from.
Joel has just asked, how will ER Studio help us with modeling in an agile development environment?
Very good question, Joel. Agile development, as you know, can be extremely fast-paced. It has a lot of benefits of the time box sprints and everything else. I've been in situations where I've been working with multiple development teams doing the data modeling, and as an example, one with 5 different development teams, all with synchronized sprints. The tools definitely help because, one, I would sit down with the teams in the different kickoff sessions that they had, and we would know what the important features were coming out across the teams on any given release. I would actually help them by actually modeling the data in the data modeling tool and then generating the DDL scripts as a starting point. But as you know, in agile development, as you're working along, even within a sprint, minor things change, that type of thing. So it really is, how do you respond to that change very quickly? The developers would change their sandbox databases on the fly. They would send me some DDL back to look at when they were doing that. I would examine it, and then sometimes the changes were just fine, but in other instances the developer didn't quite know that that concept or information was already somewhere else in the model. So I would make the minor model modifications, communicate that back out to them, and whatever changes came in would be pushed back out as net change scripts so that they could keep working, and we could check those scripts into the continuous integration builds. The tool is a huge enabler in that, because otherwise you literally have chaos because you just do not know what's going on across those different teams. This is a great topic, and one of those that we could spend days talking about, and as you can tell, I'm somewhat passionate about it as well.